Hello everyone. Today we are going to learn about factors. Let us see a simple question. How many factors does 300 have? So the simple task is to find out the number of factors the given 300 has. Okay. So I can write down one by one, like 1 is a factor, 300 is a factor, right? So I'm basically trying to write them in pairs. So 1 and 300. Similarly 2 and 150. So writing in pairs helps you reduce your time to think of every possible factor, right? So 4 and 75, 5 and 60, 6 and 50, right? Then 10 and 30, then 12 and 25, and then 15 and 20. So how many pairs do we have? We have total 1 2 3 4 5 6 7 8 9 pairs, which means number of factors are total 18, right? So we now know how many factors that this number has. Okay, it has total 18 number of factors, but this is not the always scenario in the questions. The number here for the example is 300, but the question might have a bigger number. So in that case, writing them down will not be a good idea in total, right? So that's one thing. And then this is not the only type of question that we come across. If you look at this chart here, there are many types of questions. Suppose we are considering the number 300, then they might ask us to find how many factors it has. So we already found it has total 18 factors, but out of them how many are even, how many are odd is one more type of question. Then how many factors out of 18 are divisible by 5, are divisible by 15, and so on, many types of questions like that. Similarly, how many of them are perfect squares and perfect cubes. So these are the different types of questions that we come across. So now what we are going to do here is we are going to learn a method in which we can answer all the questions written here with one method. Okay, considering the same number 300. So let us write down the number 300, and the first step that we're going to follow is we're going to represent the number 300 as a product of prime factors. We also call that as standard format of a number. So how do you write that? 2 into 3 and 2 into 150. 150 is 2 into 75. 75 is 3 into 25, and 25 is 5 into 5. So it's nothing but 2 square, 3 to the power 1, and 5 to the power 2. This is our number. Now I'm going to further split these numbers into each bracket of 2, bracket of 3, bracket of 5. Now what do I mean by that? 2 to the power 2. So 2 square is equal to 4, right? So 4 is a factor of 300, but I can also say when 4 is a factor of 300, I can say that 2 to the power 1, 2 to the power 0, and 2 to the power 2. These three are also possible factors. Say, let me take an example here. Suppose 50 is divisible by 10, right? So all the factors of 10 should also divide 50, which means 5 should also divide 50, right? And 1 should also divide 50. Suppose if I take a number 200, 200 is divisible by suppose 20, right? So if 200 is divisible by 20, then it should be divisible by 10 as well, it should be divisible by 5 as well, and it should be divisible by 1 as well, it should be divisible by 4 as well, right? So all the factors of 20 will also divide the given number. Similarly, if 2 square is divisible is dividing 300, then 2 to the power 0, 1 and 2 will also divide. Similarly, for 3 to the power 1, I can write 3 to the power 0 and 3 to the power 1. For 5 to the power 2, which is 5 square, I can write 5 to the power 0 and 5 to the power 1 and 5 to the power 2. So how many factors do I have here? I can have a combination of all these as 3 into 2 into 3, which is nothing but 18 factors. We have already calculated that, right? So this number 300 has 18 factors in total. So we have learned a method to find out how many factors a given number has. The process is very simple. I can shorten down the process here. I can make it look like very simple process. See, write down 300 as 2 square, 3 to the power 1 and 5 to the power 2, and then simply add 1 in every power. So it makes it 2 plus 1 3, 1 plus 1 2, and 2 plus 1 3, and that gives you 18. So it's matter of few seconds, and that you get, and then you get the number of factors any given number has. So we are now first of all trying to learn with the number 300, right? Let us take the same process further and learn how do you find even factors and odd factors out of the given number. So same process, you just represent every bracket for every prime number. So there are three prime numbers here, 2, 3 and 5, and I am representing a bracket for each prime number with respect to their powers. And this is it, okay? And I hope you remember now how to find the number of factors. So the number of factors are 18 already, we know it, right? Now we want to find out how many even factors does it have. So to find out even factors, what we simply do is we check for the rule. So how do we define the even factor? We define the even factor by divisible by 2. Any number which is divisible by 2 will be an even factor, right? So now divisible by 2 means I am going to focus on the bracket of 2. Now in this bracket, tell me which number is not divisible by 2. There are three numbers, 2 to the power 0, 2 to the power 1 and 2 to the power 2. Out of these three, there is one number which is not divisible by 2, which is 2 to the power 0, means that is 1, right? So this number is not divisible by 2. So just exclude that and then multiply the remaining numbers. So we have two numbers here. So how many combinations possible? 2 here, 2 here and 3, and that gives you total 12 factors, right? So there are 12 factors out of the 18 in total which are even. Now I want to find out the odd factors. So odd factors will be simply total minus the even factors. So the total factors we had were 18 minus 12 will be 6 factors. Very simple. So we have learnt to find out how many factors a given number has, how many even factors does it have, and how many odd factors does it have, right? Now the third question was how many factors were divisible by 5 or 15. So let us take the same example, 300. Okay, I represent that once again as to the power 0, 1 and 2, and then 3 to the power 0 and 1, and 5 to the power 0, 1 and 2. Now I want divisible by 5. Now divisible by 5 means I need to focus on the bracket which talks about 5. So there are three terms here, once again 5 to the power 0, 5 to the power 1, 5 to the power 2, out of which just simply discard the number which is not divisible by 5, which is that 5 to the power 0 is not divisible by 5. So that's it. How many numbers are possible? How many combinations are possible? 3 in the first bracket, 2 in the second bracket and 2 in the second bracket, and that gives me 12 numbers. So there are 12 factors exactly which are divisible by 5 in the number 300, right? You will understand this once you solve one more question which was divisible by 15. Now when we were discussing about divisible by 15, if you remember, now the number 15 is a combination of both 3 and 5, right? So can I say divisible by 15 means divisible by 3 and 5? So I need to focus on two brackets now. Check. Now there are two numbers here out of which one is not divisible by 3, so it is gone, and out of three numbers here one is not divisible by 5, which is again discarded. So how many are we left with? 3 from the first bracket, 1 from the second bracket and 2 from the second bracket, which gives me total 6 factors. So there are 6 factors which are divisible by 15. Then the next concept is how many numbers are perfect squares and perfect cubes. Same process, I will write down all the factors that I have with the number given, right? And then I will have to think about the given condition. The given condition in this question is perfect squares and perfect cubes. Now remember, for these questions always that one is perfect square and cube as well, right? So your task is simply here to find out how many terms in the given brackets are perfect squares and perfect cubes. Okay, so now first thing, let us find how many perfect squares are there. So in the first bracket, how many perfect square do you have? This is the first perfect square, this is the second perfect square. In the second bracket there is one perfect square, and in the third bracket there are two perfect squares, right? Which means total we have two from the first, one from the second, and 2 from the second. That gives me 4. So this number 300 has 4 perfect square factors. Okay, if we go back quickly to the first slide, you'll realize that there were 4 perfect squares. Let us check it one by one. This is 1, and then this is 2 second, and just find out 25 is third, and which is 100 is fourth. So there were 4 perfect squares. Okay, now the next concept was to find out perfect cubes. To find out perfect cubes, we need to again do the same task here. We need to find out how many cubes are there in the every bracket. Check in the first bracket, do we have any perfect cube here? Yes, we have. 2 to the power 0 is a perfect cube. Remember I said one is perfect square and perfect cube both. So this is one here, even this is one perfect cube and this is perfect cube. So how many combination do we have? 1 into 1 into 1, which means there is only one perfect cube. Okay, let me take one more example quickly here, so now basically we have learned all the possibilities of any number being asked. Let me take one more example, one new number, and we'll solve all the questions all together. Okay, let us discuss a number 2700. Fine, you can pause it and try it on your own, or else you can learn it with me. Now if we prime factorize this number, I'll make it quick. The number is going to be 2 square, 3 cube, and 5 square. I expect you to do it on your own. Okay, so now the first thing is number of factors. Now wait, before that, as we do it every time, we will have to form the brackets, right? So the first bracket would be power 0, power 1, power 2. Second bracket will be 0, power 1, 2, 3, and then third bracket will again have 3 terms, right? This much is clear. Now the first question, number of factors, right? Number of factors is all combinations. So 3 from the first bracket, 4 from the second bracket, and 3 from the last bracket, and that gives you 36 factors, right? So 2700 has 36 factors. Next thing, how many of them are even? Now I want to find out how many are even. So to find out even, it means I want the factors which are divisible by 2. Okay, so I should be focusing on the bracket of 2. Now in that bracket, check which one is not divisible by 2. So there is only one, which is 2 to the power 0, which means I will have to discard that. So remaining I am left with 2, and then 4 in the next bracket, and then 3 in the next bracket, right? That gives me 24 factors. So 24 factors are even. Now the third one is odd. So odd is nothing but the difference. 36 minus 24 will be 12. So 12 factors will be odd. Now the third, if you remember, was a question which I asked, how many were divisible by 5. So the fourth is divisible by 5. So divisible by 5 means I have to check in the bracket of 5, right? So this one here, out of 3 numbers available, one is not divisible by 5, which is 5 to the power 0. So I will exclude that, which means I am left with 3 from the first bracket, then 4 from the second bracket, and 2 from the last bracket, which gives me 24 factors. So total 24 factors are divisible by 5. Next question was divisible by 15. Okay, let me change the question. Let me say divisible by 10. Okay, you can solve it for divisible by 15 as well. So divisible by 10 means divisible by 2 and 5. This is very important, right? Divisible by 2 and 5. Now out of the brackets of 2 and 5, I have to check how many are not divisible by 2 and 5. So 2 is 1 here and 5 is 1 here, so I need not count them. That leaves me with the count of 2, 4, and 2. and that is nothing but 16 factors. So there are 16 factors which are divisible by 10. Then the questions were perfect square. Now to find out squares, it's very simple. In every bracket you have to check how many perfect squares do we have. So in the first bracket the perfect squares are 0 to 2 to the power 0, then 2 to the power 2. In the second bracket we have again two perfect squares, 3 to the power 0, 3 to the power 2. And in the third bracket we have two perfect squares, 0 and 2, right? So the count should be 2 into 2 into 2, which is nothing but 8 factors. So there are total 8 factors which are perfect squares, and the last one was perfect cubes. Now the cubes is where I find out total perfect cubes in every bracket, right? So if you check the all brackets, the first bracket has only one perfect cube, which is 2 to the power 0, right? Second bracket has two perfect cubes, 3 to the power 3, 3 to the power 0, and the third bracket has only one perfect cube, which is 5 to the power 0. Now the count is 1 into 2 into 1, which means there are only two factors which are perfect cubes. I hope you have understood all the different possibilities of questions based on factors. I'm going to give one example as a homework to everyone. I can expect your answers in the comment box as a yes if you could solve all the questions. Okay, the number that I'm giving you for homework is 2500. I want you to solve all the questions: number of factors, even factors, odd factors, divisible by 5, divisible by 15, divisible by 10, and then perfect squares, perfect cubes. Okay, I'll be waiting for the answers in the chat box. Thank you.